Hello, everybody, and welcome to today's presentation, Security Tested, Ops Approved, Log Management at ThreatStack, brought to you by ThreatStack. I'd like to introduce you to our presenters, Sam Bisbee. Sam Bisbee is ThreatStack's Chief Security Officer and is responsible for the security and compliance of the company and its cloud security product. The ThreatStack security team also functions as an incubation center, developing new techniques and tools for defending rapidly evolving cloud infrastructure. Sam is a security and technology executive with proven success scaling SaaS startups, joining ThreatStack early to design and develop ThreatStack's platform, bringing the product to market. Previously, he was CXO at Cloudent, which was acquired by IBM in February 2014. Our other presenter today is Lennart Koopmann. Lennart founded the Graylog project in 2009 and has since worked with many organizations on log management and security-related projects. He has extensive background in software development and architecture. His skills include Java, Ruby, Ruby on Rails, PHP, MySQL, MongoDB, and Elasticsearch. Lennart attends many InfoSec conferences and has spoken at many, including DerbyCon. And with that, I'm going to turn things over to Sam and Lennart to begin the presentation.
Great, thank you very much. Well, good afternoon, or whatever time zone you're in. Hello, and thanks for joining. Today we're going to be talking about the log management journey and kind of how we adopted Graylog here at ThreatStack. Lennart and I are going to be kind of swapping in and out here and telling some stories and talking about our points of view on kind of how and why we approach the problems the way that we do. One interesting fact that happened here at ThreatStack is we kind of turned Graylog into our SIEM, and we leverage automation and kind of a larger, more advanced architecture than most shops of our size, because we have very real and interesting threats that are attacking the ThreatStack platform. To give you an idea, ThreatStack, we provide continuous security monitoring to our customers who are operating in the cloud, where we're looking inside every single one of their servers to see what software is executing, what are users doing, what's happening with their file system and customer data. We look at their AWS CloudTrail information, the metadata, to understand the relationship between that infrastructure control plane of the cloud and what's actually happening inside the workloads. We do all of this in real time. So as you can imagine, we're an interesting target for a lot of people who want to get at our customers. And so we take security very seriously here, and we've been investing on the security team, both to protect our customers, but also in cases like this where our customers also need log aggregation. Our customers also need SIEMs and more advanced tools and automation. So we're going to go through this and kind of look at the journey of how we roll these programs out, some lessons that you could learn. And then we're going to walk through actual real use cases from the ThreatStack SOC and looking at actually screenshots I pulled over the last couple of days from our production environment, so you can get an idea of how Graylog and ThreatStack, you can combine them and go through various workflows. But this journey really began in 2014 when we launched the company and the product. Back then, there was about 4 of us building and scaling this SaaS platform where we were bringing on a couple customers. And we were in this unique position where we had an early product and we got a call in the summer of 2014 saying that we had a chance to go on stage at AWS reInvent to launch the product and company with Werner Vogels, the CTO of AWS. And so we were in kind of a hair on fire mode, and coming out of reInvent that year and going into early 2015, we actually started to experience, the first terabyte of raw data per day from our customers. And so while we were busy kind of building and scaling this multi-tenant SaaS platform and figuring out products and figuring out market fit and all those, early A-round company problems, we also needed to get insight into what was happening in our logs and in our servers. And that summer of 2014, we weren't really doing anything. We just kind of had logs sitting on boxes, and maybe sometimes we would stream them to different locations, but they weren't really being leveraged. Pretty quickly in 2015, we knew that we needed to start leveraging those logs, and we started to stream them into kind of a cheap, centralized, SaaS-based log aggregator. And that was because we were hair on fire building product and getting our company out there and bringing on our first customers, and we really didn't have the time at that point to think about installing and building log aggregation. However, that kind of changed as we entered into 2016 when things started to stabilize, right? And we had multiple reasons, which I'll be getting into, of why we needed to get off of a SaaS-based play, where that kind of cheaper SaaS-based product, it wasn't customizable for us. There were some concerns about what we were doing with those logs, and we were at the point where we needed to bring it on-prem. And when we looked at the market, we knew that we didn't want to build our own. We looked at Graylog, a couple of others, brought them in, and adopted them for our log aggregation on the ops team. And we'll be talking through how security then began to leverage that investment. But it was kind of a very straightforward progression for us. And if you look at a lot of our internal monitoring here at ThreatStack in the ops world, a lot of them go down the similar path, such as with metrics. We started with a hosted metrics provider. We ran that as long as we could until we were running into cost issues, visibility and granularity issues. And then when we were ready, we brought that investment inside of our, quote, four walls in the cloud, ran it ourselves, and we've got a lot of benefits from there. Now, this might seem kind of weird because we are a SaaS company. We provide our solution only as SaaS to our customers. We don't have virtual appliances. We don't install anything into our customers' environments other than our little agent. So it might seem kind of weird that at some of these places we're deciding to pull some of our infrastructure into our own environment. The first reason is being a SaaS company, we figured out how to operationalize technology. We do the DevOps thing, and we like to think that we do it very well. And as we, succeeded at operationalizing our own internal software and systems, it started to make sense to bring some of these systems on-prem, or into the cloud, I should say. I'll be using on-prem in kind of our environment interchangeably. So we had the people and the process ready to kind of take this tool. The other core piece was that, the core functionality of log aggregation around this time in 2016, it started to become commoditized, where you had people, starting to embrace Elk and maybe just raw Elasticsearch and all these different options. And if you spend enough time on Google, I'm sure you could have found 20 other providers and ways of just doing basic core log aggregation functionality, streaming, storing, and performing simplistic search on those logs. So we knew that, we've got the people, that's good. This functionality, it's not so unique that we need to outsource this to a SaaS-based provider. We didn't feel that we were going to get a lot of really strong incremental benefit, especially when we found vendors like Graylog who were delivering a lot of that incremental benefit off of the core log aggregation functionality, except in a way that we could control and run inside of our shop. And I think this last bullet point, given what we do as a company, was one of the most critical parts, where since we have the people and since that core functionality was seen as commoditized by our team, it didn't make sense for us to be put in a position where we were potentially leaking our customer data, internal platform secrets, or intellectual property out to a third party. This is something that ThreatStack works with our own customers on, and we are able to make them quickly feel comfortable that that's not going to be leaked out to ThreatStack. But we couldn't get that comfort with some of the other SaaS providers that were out there in the log aggregator space. So we decided to pull it inside of our environment. and start to control that ourselves. And now, a lot of teams will say, well, you can tag log data, you can go through and kind of manage it yourself and understand it. But the reality is that most engineering teams, when they're building applications, they're viewing logs as deep debug functionality as they're building and scaling their environment. And they really do need or want that functionality in production so that when a customer hits a problem, they can quickly resolve that problem for that customer. That makes, here at ThreatStack, we talk about raving versus raging customers. Any opportunity for us to optimize that support cycle and that time to customer value, that's going to be a benefit. So we don't want to put our engineers in a position where they have to be worrying about, oh, is it okay for me to log this out? Or, oh, if I have an exception or I hit an error state in this part of my application, do I need to worry that an uncaught exception or uncaught error is going to accidentally leak out internal information or customer data? We just wanted to remove all those concerns and just provide this logging functionality and debugging functionality internally as kind of a utility that they didn't need to think about and make our customers feel safer that we were treating their data properly. And Lennart, I think you've had some experiences with this with some of your other customers as well.
Yeah, absolutely. So when we started talking about this topic a good while ago, I thought that what you just described, this way of kind of you're starting your younger company, you start with something that runs in the cloud, a software as a service logging solution. That makes total sense because at that stage of a company, you kind of I think you have other problems than your logs, but we see this transformation quite often where people say we have grown and we are a serious business now, and we feel like we can't do everything with our logs that we want to do because it's in the software as a service. And they also run into other problems, and usually that's really around three things. We see a lot that people say that it can be very, very cost prohibitive to store large amounts of logs in a software as a service solution out there. These pricing sliders that they have tend to kind of start really cheap, and you feel like you're saving a lot of money, but when you as a company grow and you have more data and you want to collect more stuff, this can get pretty cost prohibitive at some point. Then we also hear people saying that because it's completely hosted, they don't have a real way to extend the system with plugins or hook it into other systems. You're always limited to what the vendor offers you. And of course, there's another problem that comes with the simple amount of data. There can be a problem with physics, I think, where the question is, how do you get large amounts of logs up into the cloud or into another cloud? So if you're running in Azure, for example, and your software as a service provider for logging is living in AWS or the Google Cloud, you are running into bandwidth problems, traffic costs, all kinds of stuff. So I just wanted to say that I think I agree 100% with you. It's a great starting point. There's really good products out there, but the moment you grow or you're getting more serious about your logs, we see a lot of people switching to self-hosted solutions. And when you hear Graylog or another on-premise solution, you kind of hear the word on-premise, and you kind of think, oh, I have to run this in my own data center, but we're already running in AWS, and how's that going to work together? Something that we learned very early on is the real difference is software as a service versus you own it. And we see a lot of people running Graylog on public clouds because in the end, it's pretty much like your own data center. It's just someone else's server. But as long as you have a Linux system, you're completely fine to run this stuff yourself. So the transformation that you did internally, I think, is something that we see a lot, and there's good reasons to do that at some point.
Yeah, absolutely. And it's funny you bring up some of those points where do volume of data and customization. As a SaaS provider, we are operators ourselves, and a lot of us came from environments where we could always just plug and play and do everything we want, and then all these SaaS black boxes started to pop up on the market. And at ThreatStack, we saw that happening, and we were consumers of SaaS and non-SaaS, and we knew the pains of that. And I think that's why, both on the agent side, where we're building data and we're consuming all this telemetry from our customers, we worked really hard to shrink that and make that as small as possible. We're monitoring hundreds of thousands of workloads, and I've never had a customer notice anything about bandwidth because the data is so much different than log data. And then on the extensibility side, it still baffles me how many SaaS-based products, especially in the log space, to your point, they don't embrace that openness because they're afraid that as soon as they embrace openness, people are just going to pull everything out of the product, which kind of says more about their product, I think, than they want to admit. Whereas here at ThreatStack, we kind of embrace that open ecosystem, open APIs, webhooks, external automation, because we realize that the more that our customers build on top of us, the more value that they get, and it just makes ThreatStack more important to them, and it kind of speaks that way of doing business that so many people in the DevOps community have really embraced. So that's great. All right. So I think, there's a very common question that we get from shops, which is kind of, why did you kind of decide to bring in a SIEM in 2017? Everybody's got horror stories of SIEMs, and this was basically the rough meeting transcript that we had back in 2017, where we were starting to become a more mature company. We had done our SOC 2 Type 2 gap analysis across the company for security and availability, and we're putting all these pieces together to be able to support our Type 2 audit period. And one of the pieces was, auditors like to see SIEMs, and oftentimes that's a requirement depending on what you're doing. And so, the kind of initial reason why we were going to do a SIEM, because we never wanted to, was, well, the auditors told us we needed to. And that both was and wasn't true, because there are real benefits to doing SIEM. It's just that you quickly fall down onto the second bullet point of this meeting, which is everybody kind of rattling off a million different horror stories about SIEMs. And different experiences, especially in more traditional enterprise settings. And so kind of off of that, we've always had this philosophy here at ThreatStack that if we're going to do something, we may as well do it right. So if we're going to go do a SIEM, let's not just default off to go pull a traditional enterprise SIEM, though we did look at them, but let's kind of look around our environment, see what existing investments we have, and see realistically, how are we going to operationalize a SIEM inside of our environment? In 2017, there was really only 2 of us who were doing security full-time here at ThreatStack. That number has now grown quite a bit. But if we were to go make a 6-figure investment in a tool, that was going to be far outside what was reasonable for us to live in every single day. So we knew that we needed to kind of philosophically rethink this and hone in. And these were our core use cases. We needed to detect, we needed to do alert management, and we wanted to do analytics. But the key is that we wanted to do it from many different data sources, including our own product. Increasingly, we had customers growing sophistication and size where they did not necessarily want to do 100% of the alert management inside of ThreatStack itself. We still have plenty of customers who do all of their alert management directly inside of ThreatStack because that makes sense for them and how they work, and whether it's because they're small or they're bigger, but their cloud is a separate from their traditional IT security. Whatever the reason might be, they're living inside that product every day doing alert management. But we looked at it and said, well, let's try and live that bigger use case, because we've been living the prior couple of years inside the product every day, dog fooding. So now let's start to dog food the bigger and more advanced use cases. If we're going to do that, we need to put, obviously, data from our own product in, but we also want to put in logs and other information from across our infrastructure. And if we've got all this data sitting in there, we may as well try and get some longer term use out of it rather than just, triggering alerts to Slack, though that's a perfectly valid use case. But we want to drive analytics because in security, too often programs are driven off of mysticism instead of data, where you've got a security crowd and traditional practitioners who have a hard time explaining what they need to do, why they need to do it, and understanding the investments that they're making. And so they just get really good at painting a picture of blood in the streets, and that creates contentious relationships inside the organization. Here at ThreatStack, we've got internal transparency, cultural kind of points that we really strive and care about, but we also didn't want to be operating that way. We like to make data-driven decisions internally, including on security. So it drives our priorities. If we have somebody that needs to go and address privilege escalations in the environment, or what software is running in our environment, they want to go in, look at the data to see what's actually happening. And then we say, okay, if we're going to go spend 30 days to solve this problem or de-risk this behavior, what do we want this graph to look like after 30 days, right? And how can we do that across multiple inputs, whether it be from our CDN, from our application logs, or ThreatStack itself? And we're going to go through some use cases like that at the back here. Now, I think it's important to note, a lot of companies just kind of jump into the SIEM space. And I think, in my prior life as working in kind of, larger data systems and distributed systems, you always had this kind of preference to just start throwing data, whether you knew its value, whether you knew what it was doing. We're just going to keep filling data into this massive Hadoop cluster, where you're going to create a quote data lake or bog or whatever people call them now. And then we're just going to rub some machine learning, we're going to rub some data science on it, and the Oracle of Delphi is going to rise out of it and tell us all these important things, improve business value. So we knew that that was a bad strategy and that wasn't going to work for us. So we went into this eyes wide open that we were only going to pull in specific piece of data that we knew was going to be actionable and that we knew that we were going to be able to work with. If it wasn't actionable, if we weren't able to work with it on some regular cadence in the team, there's no point in us streaming it in and storing it and doing anything with it. We also had a dedicated security team. I think a lot of ops teams that are small and constrained, they're having hard enough time spending their life inside of multiple ops availability, reliability panels that are telling them interesting things for their day job. Thinking that they're then going to spend a lot of time off in security tools doing the same thing can get tricky. Some teams are able to do it, and they do it very well, but not all of them are. And I think it comes back to the kind of old adage that, sure, everybody's responsible for security, but not everybody can own security. And so we had a core group of people who truly own security, were living it every single day, and they needed their dashboards, and so that made sense. But we also had a mature detection program where, we were not just kind of throwing out every single piece of detection technology. When we were deploying IDSs and other components inside of our environment, we would never just turn on every single rule and just get blasted by noise and just say, oh, well, this isn't going to work and we're just going to have alert fatigue and let's not do anything about this. We take more of kind of a structured approach of, we have a hypothesis, let's deploy a piece of detection on that signal to prove or disprove that hypothesis and see what happens. Or we'll make assertions about our environment. So one of our favorite IDS rules internally here at ThreatStack is we sev one page, even at 2 a.m., doesn't matter, if somebody runs the command ping. And that's because 4 years ago, we disabled ICMP echo, or the ping protocol, in our environment because we had better availability checks than that. We had, advanced sensu and all these different checks in our environment, so nobody ever had a reason to run ping. And we could find our servers very easily with automation. But ping is a common tool that somebody might run if they don't know that. And so that's a quick assertion for us to make. And the two most common things that catches in our environment is either more junior engineers and operators who don't know our tool stack as well. And so if they're running ping and just kind of messing around production at 2 a.m., we definitely want to know about that so that we can correct that behavior or teach them the proper tools. Or, in our last pen test, that was one of the rules that fired within seconds of the pen tester once we gave them access onto a host intentionally. They were on that host and they started running all these commands, including ping. that was an assertion of our environment that failed, and so we got alerted to it immediately, right? So we had these different components already in place before we brought a tool in, right? Too often people just throw more tools at the problem. It's like, oh, I've got more alerts, oh, I've got more things, let me just buy more tools. It's like, well, if you have the wrong tools, then buying new tools is the right idea. But you always need to remember to have people and process to back up those tools. Otherwise, you quickly get shelfware. We knew that we did not want to build or duct tape multiple open source solutions together. We run enough Elasticsearch in our lives. We run enough Cassandra. We've got this very large platform. We've got bigger problems to solve than running more Elasticsearch and running more tools to do log aggregation. Too often people will say, oh, security tools like a SIEM or something, if it doesn't say security on the label, it's not good for security. It's kind of like a lot of tools out there will do host config checks. Is your file system configured according to NIST standards? Well, I don't need to go buy a product for that. I run Chef in my environment, and I can just have Chef basically assert my environment into that good state. Or I could use Sensu to already do that. And the point here is that we were leveraging investments that our ops team had already made. Where the ops team was larger than the security team, they had already tech selected, deployed, operationalized, and were living in those tools. And we looked at them and said, oh, we can get exactly what we need from them without going buying anything more, without going deploying anything else. And then we get the added benefit that both teams are living and breathing in the same tool. So that's pretty cool because we can start to share a lot of value. Lennart, I think this is where you've been working with some of your customers. Oh, we might have lost Lennart. All right, no worries. All right, going on to the next one. So as we were progressing in the SIEM, we decided this is kind of how we were going to roll everything out, right? We carved out indices in Graylog, where our auditors and kind of in general, companies are very worried about, as alerts are firing, as you're doing security monitoring in your environment, can the right people see them? That's most important. But then there are occasionally cases where you don't want the entire company or everybody to be able to see those alerts. There could be HR issues where, there's a rule that says, hey, we're about to decommission and terminate this employee. So that gets logged out or that gets alerted or you're starting to see different behavior. So there are their HR implications. Or, if somebody's acting as an insider threat or a bad actor, you might not want them to see every alert that you're firing about their behavior internally. So there's always a bit of a transparency question, and we kind of walk that line very carefully internally here at ThreatStack, but we knew that we needed to carve them out. So we had special space inside of Graylog for us. Then we looked at the data and kind of went through that, middle school science lab process of having hypotheses, proving those hypotheses, and moving on them over time. But as we did that with our application logs, we then started to bring in ThreatStack. And over time, we just keep adding more and more data sources so that we can look at them, understand them, prove them out, and do a lot of those analytics pieces that we talked about. So as far as the actual how we did on the technical side, so we already had the existing application logs in there from multiple vendors. And we could have kind of gone in and done native Graylog, or there's a lot of different ways that you can ship data into Graylog or these other solutions. But we were looking and we knew that not only did we want to put data into Graylog, we wanted to do automated actions based on what was in Graylog, whether that's doing correlation across multiple event streams, reacting to alerts, whatever that might be. We also wanted to pull data out of Graylog, enhance it even more, and then either route those insights to our responders or maybe the employee who caused that alert, or we might want to put data back in, and so into Graylog. So it was just kind of this natural workflow cycle that we knew that we didn't want to just tackle the streaming data into Graylog problem. And this is often seen as an anti-pattern, is to adopt multiple new techniques or multiple new tools at the same time. One of the reasons we decided to do it, though, is because we index very heavily in programming and security engineering on our security team. We have not invested very heavily in more traditional information security analyst type of roles. Most of the team is writing code and living in these systems every day. So it made sense for us to leverage automation, invest heavily there at the same time that we were investing heavily in the log aggregation and SIEM side. And I think I actually messed up on the last slide. I think this is where, Lennart, you want to talk about some of the pieces that you're working on with your customers and their stories.
Absolutely, and so I wanted to say exactly that on the previous slide. But I think that was for the next slide. So go to webinar would just show me when I click the unmute button. It just showed me this empty dialog box. So computers are still on our side today, apparently. It seems to work now. So we do have. So I think this is a fantastic story, and I think this is something where a lot of these software as a service solutions really fall short. That is simply because if you want to automatically interact with things in your environment based on things that happen in your logs, you really need to have something that runs in your environment. You don't want to, for example, for a use case that I really like is that one of our users is based on an alert in Graylog. He is triggering a Python script, which is then automatically pulling a memory dump from the machine that triggered the alert. So they have a bunch of sysmon deployed on workstations, on Windows workstations, and they automatically remotely log into that box and immediately pull a memory dump and secure the whole system, and then shut it off from the rest of the network. So they basically pull a state that they can investigate later, and then immediately isolate the system. You can do this on things that you have very high confidence on, obviously. You don't want to do this for every kind of low confidence alert and shut people's workstations down, but these kind of integrations I think are really interesting, and I can say that Graylog as a product, we are about to come out with our 3.0 version, which makes a big leap forward in visualizations and especially security workflows, making a security analyst's life easier, besides a lot of other things. But we'll be pretty much right after that, we're going to we'll start to work on new alerting functionality. And the plan is to, in this alerting functionality, kind of move more to a concept of triggers. That means that you will be able to automate things automatically out of Graylog, basically. So I really like these use cases. This is where on-premise software really shines because you can integrate it. And then, like you mentioned, keeping your data open and keeping it accessible to the rest of the organization is where you can really build these super nice use cases and do stuff like that.
Absolutely. And so then this is kind of the architecture that we ended up landing on. And, you know, I like that use case that you mentioned of going and doing a mem dump on that endpoint. You know, one of the versions of that that's often talked about in cloud environments where you're supposed to treat all your servers as cattle, not pets, is people say, oh, you just go terminate the server. And I think that's a very cool use case that a lot of people talk about. And when you get really sophisticated, that's a great one. I think most ops people hear that and they just hear availability nightmares all over. Which is, you know, to be fair, it's really no different than when back in the 90s, our routers and firewalls started to put in active DDoS prevention. And then, you know, you would get your web page would be featured on Slashdot or whatever, and you would suddenly be taken offline because the business was working. So, you know, for example, internally, we play with different use cases or with our customers where maybe instead of just terminating that server and, you know, just going around your infrastructure, terminating servers and creating a DOS event of yourself, maybe instead you just go update a security group on that EC2 instance and you say, hey, you just did something weird. So instead of going into the host where the malware is running or the actor is and then being able to potentially block you from doing that, just make an API call to AWS, apply a new security group rule to that EC2 instance that blocks all network egress. Now I've still got my standard business traffic coming in, flowing through my architecture, but if malware landed on that box, is not able to do command and control or anything back out. A lot of different use cases where you can go in there. But this is the kind of architecture that we landed on, where we built our own internal orchestration system. Again, the primary reason we did that was because we index so heavily on coding abilities that we really wanted that flexibility, because when we looked at pretty much every commercial security orchestration product, or SOAR, it's an unfortunate acronym, but for that market, but the SOAR market, a lot of it was kind of cookie cutter and run books and square peg round hole, and we just didn't really want to do that. There are ways to do it very successfully. We just didn't feel like that was the place that we wanted to plug in commercial products that were too cookie cutter. But we started pulling Cloudflare logs. They do all of our DDoS active mitigation, our threat stack alerts, future data sources that we keep bringing in. Depending on what we see in an automated way, we can issue Slack alerts or page people. But everything that orchestration system sees, it drops into Graylog, and intro logs are landing there too. So that's how we can get a full picture from out at our very edge before it even hits our servers out of Cloudflare, all the way in through the application, our host, our infrastructure layer. All this rich telemetry and alerts and indicators are all landing in one place, where the security, ops, and engineering teams can collaborate. And then when things are seen and issues happen, because issues always happen, we're able to route them more efficiently across the organization. So now we're going to walk through a couple of real examples. And when I say real examples, that means that we're not, looking at Hollywood movie, nation states, organized crime, craziness. We're instead going to look at kind of some day-to-day ground truth examples that blue teams are living every day because they don't live in LA in a Hollywood movie. These are also screenshots that I took directly from our production Graylog and threat stack instances. So I would love to show you the full UI of every shot, but we had to kind of scope it down a little bit to just a specific area. So I apologize, I can't show you the full beauty of Graylog's UI and threat stack's UI. Our designers will be sad, but understanding. So here's an example where we were analyzing privilege escalations. And this was a project where, on a regular basis, we look in and we say, hey, okay, in some cases, we need to let engineers into production because they help run this thing. And so when they do access production, what do they do? And kind of how often are they escalating privileges? Why are they escalating privileges? And, as you can see over a timeline like this, there's actually not that much happening. But then you see a spike in your graph. I say, okay, well, that's interesting. There was a lot of privilege escalation on that day. The next question is why? Again, this is not Hollywood. We don't have some magical hologram saying, well, it's these people and this is what's happening. Anything in incident response is just like in ops. It's a series of debugging steps. So, okay, we see this jump. What's going on? It could be something bad or it could be completely fine. So using the quick values functionality in Graylog off of that search, we said, okay, for all these threat stack alerts about privilege escalations, let's start to pull out the users. And so here's a quick values of all the users that were escalating privileges across that 7-day period. And you can see exactly there with the red arrows, the top 2 users were representing 79% of all the privilege escalations in the environment. So it's a good bet that that relates to that big spike in the previous graph. So now this is where we're going to punch in again. And here's where we then modified it to aggregate on arguments and then also stack it with the usernames, right? So off of the quick values in Graylog, say, okay, this is an interesting search. Pull out the aggregate arguments from the threat stack alerts, aggregate them, and then re-aggregate on the user who is performing those escalations so that we could determine whether or not different users were escalating privileges for different reasons in that period. One user might have been going in and doing perfectly legitimate operations and maintenance. The other one might have been using that availability event as a smokescreen to go in and start to fiddle internally in the systems. But when we look at it, it's all pretty straightforward. It's fairly flat distribution across what they were doing. They were having to go in and do some manual installation where there was probably a bug in a chef cookbook or something, and they had to pause the automation for a moment, go in, make these servers act correctly to restore some functionality for a user, make sure that there's no business impact before they turn the automation back on. But this, to me, as a security responder, I look at this and I say, this is perfectly reasonable. This is why we have break glass access into our environment. I might decide if I see this happening on a regular cadence where they're having to go in and break glass daily, weekly, then I might have an issue and I might decide, you know what, I need to invest some resources here in more automation so that they don't have to break glass as frequently. Maybe I create an automated task, an easy button from the jump host where they can log in the jump host, mash the button, say, hey, stop automation, make things calm, and then move on. But I can make an informed decision about that investment as an executive because I see this right here, and it does not happen that frequently. So here's another fun one where at some period we started to get a lot of threat stack alerts because config files in the etc file system were being edited. And that's never a really good feeling. And when we saw that spike, I said, all right, what is that? Go in, run quick values on the commands that were editing the file system. And the reason we're able to do this at threat stack is because we're not hashing your file system, kind of like a traditional product would. We actually listen for file system events. So not only can we see when a file is edited, we can also see when a file is opened. That gets really powerful because, one, most advanced adversaries are intelligent enough to not edit too many files, but you also tend to find things like malware on a host that's scanning your file system for interesting information. Or the far more common occurrence, a summer intern logging into production and poking around where they shouldn't because they're, quote, learning. But in this case, that's not what was happening. We actually saw files being edited. And when we looked at it, the spike was coming from ldconfig.real. Before I drill in on that, I also see while I'm going through this activity of understanding what's happening in my environment, I also see down below that it looks like there's some manual file editing happening in my environment. So I'm going to make a mental note to myself that that's another piece of analysis that I'm going to come back and do later. For whoever it is in my company that runs Nano, that's somebody that I'm going to go and talk to and say, hey, here's a real text editor. But I then punch in to threat stack because I could do some additional recon and analysis in Graylog, but this is a weird enough event of all these config files being edited by ldconfig. Let's assume that I don't know what ldconfig does. This feels really bad to me. I want to get to the forensic view of the deeper dive really quick. I pivot over into the threat stack interface in my alerts, and I look in and I see, okay, here's my ldconfig. It's running out of sbin, and it looks like it's modifying ld.so.cache. All right, let's also assume they don't know what that means. I look down at the heat map and I see, okay, this is actually happening in a fairly repeatable and deterministic way. Yeah, it's spread across my environment, but my environment is spinning up, spinning down, expanding, chef's always running. So maybe there was something happening at that time on those days on those systems. Clicking through the interface, this is the actual raw syscall that actually caused the event that you get with your FIM event, where I see, okay, yes, ldconfig ran, it was running as a root, it was not in an interactive session, and it was with a -p operator. I don't remember everything about ldconfig, so I run man ldconfig and I look up at the documentation, and apparently what that does is it prints the list of directories and candidate libraries stored in the current cache, right? So all that this likely is automation in my environment that's going in and performing this action. It's probably in a chef cookbook. It's probably in some part of our automation. At this point, all of this pivoting that I just did for this one alert that was happening so frequent in my environment that looks so scary, magical arcane Unix incantations, having to go into the documentation, whatever. But I can actually, this took me roughly a minute, right? From the time I saw it in Graylog to pivoting over to ThreatStack, and then probably another minute or two, I got my answer. And now I know, oh, this is perfectly normal. I could maybe go spend the next hour, depending on the type of analyst and responder I am, maybe I go spend the next hour or two digging through Chef to figure out what's actually causing this so I can fully understand it. But probably not, because we've all got very busy lives. And so in ThreatStack, I can just suppress, hey, if root running out of the root directory runs ldconfig with a -p argument and is not an interactive session, please do not alert me. Just suppress that right out of my environment. And then you see your alert count go down, right? And so that's just another example where using these behavioral signatures, you're making assertions and understanding your environment and suppressing and honing it as you go. I will also comment that this has a great advantage for when something does go bad and does go wrong as an analyst or a responder. If this is kind of my week to week, I'm not even saying day to day, but even if this is my week to week or month to month life, being able to understand so quickly my environment, make these assertions and understand how it behaves when malware does land. When I do get a letter that says, hey, customer data was leaked from you, please go in and do forensics, whatever that might be, I'm going to understand my environment so much better, and I will be so more effective on that incident response that I'll be able to most likely dive exactly to where I need to go, or if I need to review alerts, I'll be able to dismiss and cull through a lot more data a lot more quickly. Because I'm not looking for indicators of compromise, not looking for those big positive, scary things that probably never happen in my environment. I'm actually living my life trying to understand my environment and understand the security and operations. So that's our webinar. That's how we're kind of using Graylog and ThreatStack here at ThreatStack. At this point, we're happy, Lennart and I are happy to answer any questions that you have. We covered a lot of material. It looks like we left exactly 10 minutes for questions if anybody has them.
All right. Our first question is, in addition to the internal orchestration app and Graylog, what other monitoring tools are implemented at ThreatStack for visibility?
Yeah, no, great question. So at a high level, we get to play with a lot of different things. So we probably are running multiple experiments with multiple different tools at the same time across our environment, whether it's open source or commercial. But when you kind of look at our core alerting visibility stack, it's obviously ThreatStack, it's obviously Graylog, it is Cloudflare. We also do a lot of work to actually modify our application logging to act as kind of a pseudo AppSec internal business logic indicator where somebody might be attempting to access another customer's data from their account. So kind of more customized app logic there. But then the rest of it is kind of that note that I made of we leverage ops tools. We leverage Sensu, we leverage Grafana and Graphite and StatsD and pretty much the exact same visibility tools that our ops team is using. We're actually looking to bring on one or two other commercial vendors in the AppSec space pretty shortly here, and hopefully I'll be able to talk about that pretty soon in coming months.
Great. Our other question is, using an orchestration app and a log aggregator seems like one way of applying DevOps to security. How else, if possible, can companies set up their tech stack to achieve similar results?
Yeah, so I think it kind of goes back to those core decisions about how your team is structured, how you're making those investments, and understanding what makes sense. If you have a more traditional information security team who does not index very heavily on coding and chef or whatever it is that you're using in an environment, it might make sense to kind of use more of the internally built functionality inside of Graylog. As Lennart was talking about, you can customize it very heavily and bring in all this different functionality. So maybe it makes sense to kind of forego the automation route and just kind of live and breathe inside of that tool itself. You can still plumb threat stack directly and Graylog and all this. It's just without less custom code. I don't know, Lennart, if you want to talk about some other common deployment models and your customer base, and if they're not kind of rolling automation on top of it, how they're typically leveraging Graylog.
Yeah, so we really see a lot of people running automation on top of that. I think that there is, we also see a lot of people kind of using Graylog across the stack to kind of not only monitor for security, but also monitor for their in their development environments, monitor kind of the health of their applications, all of that together. And we see a lot of things where people actually use automation even in these other use cases, because Graylog in the end is a very generic, I would say, log management platform, and it's very popular with security use cases, but it's in no way limited to only that. Like you said that you already had a big investment internally in Graylog in the operations team. We see that a lot, that it's being used really across the stack. And then there's so many ways that you can use Graylog with other integrations. For example, what's a good one? So we see a lot of integrations also with other security tools, where, for example, another system or maybe even another SIEM would send logs into Graylog, and then people will go into Graylog for kind of the incident response and stuff like that. We have a few good examples on our blog, and we also have the Graylog Marketplace, which is on marketplace.graylog.org, where people can link to their GitHub repositories with kind of guides and plugins and stuff like that. So there's a lot of ways that you can kind of build a whole ecosystem there with something like Threat Stack and Graylog in the middle.
Great. That looks like it was our last question. Is there anything you guys would want to add before I close things off?
I'm seeing one question in the questions form. I don't know if you guys can see that, or that only went to me.
Oh, yeah. So, question is, I recently implemented Graylog, and I am quite happy with its capabilities. I've been experiencing a corrupt journal as of late, and I've had to delete it often. Have you experienced this issue? If so, can you advise on a permanent solution?
Yeah, and I think I can take that. I think to actually debug that would be great to kind of post this into one of our community channels, so we can help you with that. What is, I think, interesting for everyone though is the journal is what's sitting in front of Graylog, and basically every message that comes in is being written to this journal, which is a disk persisted queue. So if you have any issues with Graylog itself or the architecture behind it, you'll never lose your messages. They're basically persisted on disk for a very long time. We are actually using Kafka internally. We're using code from Kafka because Kafka is great at writing append-only files to disk extremely fast, and this is what the journal is doing. That is, of course, if that gets corrupted, that is, of course, very unfortunate, and this is what this question is about. I could see maybe as a starting point, we usually see that when people run out of disk space, you would end up with a corrupted journal. The other reason could be if you're somehow mounting that journal from a remote location, then maybe you should look into if that is a reliable connection, if this is the proper, file system that's being used in the proper way to mount it. If none of that is the case, then just post this question to our community channels, and then we'll be able to help you there. In general, we only see a corrupted journal when people run out of disk space or there's an issue with the mounting. This should not be a permanent case, so I'm sure we'll find a solution there.
Awesome.
Well,
And with that, I'd like to thank Sam and Lennart for a great presentation today. I'd also like to thank today's sponsor, ThreatStack, for providing our audience with a great presentation. And lastly, I'd like to thank the audience for attending, and we hope that you learned something that will help you in your developer career. Have a great day, and we'll see you next time.